Let's see what is a unit hydrograph and how it can be deducted from the given hydrograph. Mhm. On a screen, you look at this problem. All in red ink is a problem statement given, out of which you have to try and derive a 6R unit hydrograph, and hydrograph of 6R is given. So both are same, so we need not to look at the complexity of say change in the duration of the hydrograph. Rainfall depth is given 7 centimeter. This is not effective rainfall depth, but just the cumulative rainfall depth is given. We need to look at this table data given very microscopically, like time is mentioned here 036 hours, and then the ordinate of the hydrograph in cubic is mentioned, and these are the coordinate of the hydrograph, and cubic meter per second 1535. This is in centimeter rainfall, and this is discharge basically. Hydrograph represents the discharge versus time graph. So that difference we must understand. Infiltration loss in terms of phi is given 0.5 centimeter per hour, and this has lasted for 6 hours. So total loss of water in terms of infiltration, you can say 0.5 into 6 is equal to 3 here. This is 3. So now this, if we deduct from the given rainfall depth, then what we get is the effective this rainfall, and which if I deduct from 7, I get 4 centimeter of effective rainfall. So here unit hydrograph. This hydrograph is of 4 centimeter, 6 hour duration, and it produces 4 centimeter, 4 centimeter of uh, depth in the catchment. 4 centimeter of the depth in the catchment. Unit hydrograph is a particular hydrograph which produces 1 centimeter of uniform depth across the watershed or catchment, across the uh, uh, catchment. So what we need to do that we need to first look at these values, these values. If this is of the direct runoff values, which is not, because here base flow is mentioned, we have to deduct base flow from this, and after deduction of base flow we have to divide by 4 centimeter, because we need all these ordinates for 1 centimeter. So ultimately we'll get a new chart, new graph, cubic versus time, that is the discharge versus time. So that would be our the final hydrograph of 6R. If we need to change this time, then we have to adopt a different method, like S-curve method or superposition method, that we'll learn in some other video, but presently let's go to the next. Here these are the value. The first red is the problem given, and all are plotted. All discharge cubic is plotted against time. This, and the second is when we reduce that 15 cubic of base flow, then we get it the similar one. And if I divide these all values, all these values, of blue line by 4 centimeter, then the ordinates which I get is of unit hydrograph. This is unit hydrograph. So after removing base flow and then getting the ordinates for 1 centimeter are the ordinates of unit hydrograph. I think this diagram is very representative of that, what is the unit hydrograph. Basically we derive this because this is a very unique representation of given catchment. This is a response, direct response of the rainfall which has occurred onto the watershed or catchment area. and this can be used for further studies to predict, forecast the values of discharge in river for different rainfall activities in the given watershed. Similarly, the problem could be like a hydrograph coordinates are given to you. All red ink are given the second problem. We are looking here at the second problem. Area of the catchment is given to you. That is 100 square kilometer. Base flow is 12 cubic. Base flow is given, and ordinate of unit hydrographs are asked. So this is the values are given. These are the flood hydrograph ordinates. This is base flow. These are the ordinates. If I deduct this base flow, then I get the ordinate of direct runoff. And what is asked? The second point is that ordinate of unit hydrograph is asked. So we need effective runoff. Effective runoff is not given here, and ordinates are given. If I sum up all the ordinates of direct runoff, then I get the discharge from the hydrograph. This 2254 is the discharge coming out of this watershed or catchment area. So volume of water is this DRH is 3. 3 is the gap here, 3, 6, 9, 3 hours, 16 to 60 in terms of second, and sum of all the ordinates, that is 254, give us total volume. And if I divide by the catchment area, which is given as 100 square kilometer, I'm converting into meter, so this is in the denominator. So this here, if I divide volume divided by area, what I get is the depth of water in the catchment. That is nothing but the total depth, say 0.3 centimeter. 3 centimeter of rainfall in the catchment. Now this 3 centimeter is the flood hydrograph depth. We need unit hydrograph ordinates. So all these ordinates of DRH need to be divided by 3. And here if I plot against time, then these are the ordinates. These are all the ordinates of unit hydrograph. Let's go to next one more problem in which simple this number 10. Here effective rainfall is given to you. Area of the catchment is asked. In the previous problem, numerical problem, we have calculated here. Here we are calculating area. So simply you change this formula that area of the catchment is the volume divided by ER, effective rainfall. Effective rainfall is given in this numerical problem. So volume is placed on numerator. Here denominator is the effective rainfall, that is 5 centimeter cube. We'll come out with the area. So this is the total area of the catchment, and then we can deduce the total 6R unit hydrograph from the given that I have not explained in detail here on the screen.